Looks like we're live, so we'll just do the quick test to make sure. Come on. So we'll just do the quick test. Yeah, it said it 3 times. Very good. Excellent. Just add a little extra confusion. It's always good to have a little confusion. Don't want everything to be too easy. Got to make people work for it a little bit. Maybe. Maybe that's just cliche mush. Probably cliche mush. All right, so I'll just read a couple of comments and just to start, just to do the fair interacting with the people. What the hell is all? Did I read these already? Sometimes you have to forget about what you know. Well, it sounds like something I could respond to, but that sounds like crap. But anyway, sorry. That doesn't sound right to me. All right, learn something about electricity. Whatever. Dielectric and charge. I'm not a female. All right, well, I'm just saying you've got a name, Melissa Miller. I'm supposed to know. Regardless, I don't need to learn something. I'm proposing something quite directly. I'm directly stating, making a claim. And I'm opposing another claim made by others. And I'm explaining why their claim is inconsistent with the evidence and logic, and while my claim is consistent with the evidence and makes logical sense. That's what I'm doing here. Now, maybe you're confused, like with your, you can't figure out that, maybe I shouldn't be riding on a woman's name. But, that's your problem, not mine. Anyway, that's not my name. Okay. I'm a big burly fucker. No, we don't do that word here anymore. Who would skull? Well, you literally, whatever. Oh yeah, I'm impressed. Yeah, internet tough guy. If you spoke to me in person, same way you do on video, I don't know. Okay, you want to have some kind of cage match? Fine. I like learning what y'all. So that doesn't really. Not very impressive language. It's probably worse than saying skull fuck is saying y'all. Have to say, but need to, when you type it, it just looks even dumber, frankly. Need to learn any name calling, but need not learn any name calling. Well, I'm just saying you talk kind of crap and then you complain about name calling. That doesn't make much sense. I use many other people's computer to learn what you contribute. Well, I think you don't have to use other computers to do that, but fine. I'm sure your theory is accurate beyond most theory except for the ether. So again, there's no evidence, rational evidence, for ether. So you want to present some evidence, then that might be interesting. But like God, it's just some claim. You claim there's the necessity to have some sort of mush in the universe that things mush through. I'm making the simple argument that once you have a thing that mush is, you don't need the mushable substance anymore. You just don't need to turn everything into a wave. Just no reason to. Things can come in order, like dogs tied to a sled. Dog 1, dog 2, dog 3, dog 4. You don't need to turn them into waves of dog. All right. I'm going to delete these comments just because I don't like them. They're just kind of unappealing. Anyway, sometimes you have to forget. I don't need advice, okay? I'm really not interested in advice. Either make an argument or you say something like, wow, Gary, you're totally I'm learning so much and you're so brilliant. And gee, I wish I could think as clearly as you do and blah, blah, either disagree or agree, but I don't need advice. Don't want it. Not soliciting any, not asking for any. All right, sometimes you have to forget what you know to understand what others are proposing. Yes, and obviously knowledgeable people have to know that, oh yeah, kindergartners don't know what a hyperboloid is. So I can't say hyperboloid and just assume they know what I'm talking about. Yeah, yeah, that's right. Yeah. So when you're a smart person doing something smart, you have to understand that your audience might not know what your little fancy words mean. Now, Ken Wheeler has no clue. So maybe you ought to give this advice to him because he constantly uses words that nobody knows what he's talking about. The lack of inertia, for example. How do you have a lack of inertia? Anyway, yours, Ken's, and Roger's theories combined make sense put together to an asshole or an idiot. Oops, I wasn't going to say bad words. To somebody who is not thinking very clearly, maybe somebody who's on drugs or was in a motorcycle accident, wasn't wearing a helmet, that kind of thing. Maybe that's true to them because they aren't thinking straight. But for most logical people, they understand when one guy's saying it's black and the other guy's saying it's white, or one guy says it's up and the other guy says it's down. Those aren't agreeable theories in any way. They can't be combined because they have a direct contradiction built into them, a direct contradictions. I don't, there's no premise for which my theory combined with anything Ken Wheeler has to contribute, it makes no improvement to any aspect of anything I'm talking about. I don't need hyperboloids. I don't need wavy things and toroids and tornadoes, and I don't need any of that crap. Theory works fine without any of that nonsense. But I find that really an offensive comment. I mean, it's offensive to have my theory thrown in a bucket with these people. All right. You are doing better with your temper and verbal vocabulary. Or, no, vulgarity. Well, again, you're doing worse, skull fucker. We really don't need that kind of contribution here, potty mouth. Thanks again, whatever that is. I don't like people writing more than one comment on a video. I can sort of tolerate two if you got a lot to say, two different subjects maybe, but there's just no need to make repeated comments on the same video, in my opinion. There's no need to do that. All right, please go back to Penn diagrams. Yes. The diagrams need some work. I'm working on it. I've stated I'm working on it. I've pointed out why I have some difficulties. Linux operating system combined with broken technology, and it makes it a little hard. And I'm working on it. So quit complaining, whiner. Sorry, but it's just whining. You could just say, you could just keep this. The current artwork is not doing you justice. You could just say that part, and that would be enough. Try a pen and tablet. I mean, it's just so retarded to say that to me when that's exactly what I was doing. Ill-informed person. Yeah. Jeez. Not helpful at all. There was a slight increase in the amount of radiation. So this is Dick Woodman, who is 50-50, in terms of useful. Amount of radiation in one of the world's big telescopes. Why would I care? Is that interesting to me somehow? Does it have something to do with what I'm talking about here? Yeah. And it was supposedly determined that it came from a black hole collision. It was supposedly determined, and again, you're just telling me some other story, and I'm supposed to, first you think I know this, or first you think I care. Either one of those two. And I don't know why you would think so. In the Andromeda Galaxy. Okay, so they saw something in another galaxy. Look it up, Gary. Why do I want to do that? And explain to me how the fuck, it's not a unnecessary language, that's possible when in even get any kind of image of Andromeda, you in the first place have to do a timed exposure, lens exposure, so that you can capture enough photons for it to resolve into anything. Yes, well, the fact that it's a time exposure doesn't negate the idea that they could be sensing more than one kind of radiation in the telescope. So the telescope could have a sensor that's detecting X-rays or something else also in the telescope. It's possible. I would imagine. You said determine it came up with a, let's see, what'd you say? Amount of radiation, a slight increase in the amount of radiation. So radiation in what form? Was the telescope looking? What was it looking for? I guess you'd have to say what kind of telescope it was. Was it actually an optical telescope or was it a radio telescope? You know, this is just not terribly useful. Clearly, the radiation wasn't in the form of photons, right? That's pretty clear what's being argued here. And we know that sometimes these galaxies do shoot, you know, stuff goes supernova in very specific ways. You know, there's especially from the center of galaxies, you have these beams of high energy particles. But who cares? To me, that's physics that's really really doesn't have anything to do with either relativity or quantum mechanics. It really doesn't have to do with diagramming the basic mechanics of the universe. That is why the universe is, what makes it work. What's the working mechanism? That's that's way down the Rube Goldberg scale. Okay, that's a bunch of complex matter in a very complex system, and so diagnosing why is a lot more complicated, and you know, it just isn't it's not what I'm dealing with. Thanks, but no thanks. All right, a new spectrum of unknown electrons traveling in different geometric shapes and frequency, question mark. This is another thing that just has no value. You know, when you make comments to some sentence in a video, in the comments section, without quoting anything, there's no context here. I have absolutely no idea what you're talking about. A new spectrum of unknown electrons. Electrons don't have a spectrum. Electrons are like photons in the sense that they're all exactly the same. But electrons don't travel in frequencies. You know, you have to shoot them in a frequency to have them in a frequency. There's nothing that naturally produces electrons at a frequency. So there's no unknown electrons traveling in a different geometric shapes and frequency. It's not what electrons do. So I have no clue what you're talking about, Bubba. I don't know what your real name is. Moose. Moose. Well, it goes Moose, like Melissa. Moose. You know, we'll call you Moose. All right. How about unknown isotopes and ions? So unknown isotopes is just saying a variant of an atom, and most isotopes have very short lifespans. So why would it be relevant? An atom in an unstable condition for a few seconds, and what again? I have no clue what you're responding to. There's just no context to this comment. It has no reference. It can't mean anything to me. It certainly can make anything to anybody reading it. Can't make anything of it. Yet to be discovered. So ions and isotopes. Ions are so common. Like almost all the elements make ions. So I don't know how it'd be yet to be discovered. That doesn't even make any sense. So I can't even do anything with that. I mean, some atoms are really stable, like, the noble gases and stuff, but are understood the possibility could be. Are understood the possibility could be. Not written very well. Yeah. I'm not going to give you any points for that comment. Yes, no points. You look like Jim Morrison with blonde hair. I think it's doubtful. He was a lot prettier than I am. But who cares? It's not really all that relevant, so we'll delete it. You know, it's kind of complimentary, you know. Just isn't relevant. Good work on the public speaking, doing better. You already said that on the other video. So, yeah, stop it. The James McGinn. So the global warming denier. You know, it's kind of funny. I mean, he's really obsessed with water molecules, and I mean, water is one of the biggest, most powerful of the greenhouse gases, and there's such an obvious correlation between how much water vapor you'll hold in the atmosphere and temperature, and it's just it's just surprising that somebody who understands water would think climate change isn't a reality. Anyway, this is a step in the right direction. Okay, well, but I think you need to do something more dramatic. Obviously, that's the scary part, is, putting on clown shoes and doing antics, and, you just hate to do that, to have to create interest. I mean, it's, that's like becoming part of the Borg, part of the game. It's like I could put ads on my videos, and that might make them, Google then might put them in the related video thing more often, and they get in the feed more. But it's like such a despicable thing to have to do, to sell out. Right now, I see you being in the shell of your own theory. Well, you can see it any way you want. I mean, clearly I'm, obviously, in my opinion, clearly not in any shell, in the sense that I'm aggressively seeking somebody to talk to in this room, to put somebody in the other chair. I even, later on, I might talk to a virtual physicist, because I can't get a real one to show up. Little heart. Yes, there's a pink heart in my house. I have no idea why it's in my house, but it was on a stick, and I said, oh, I can tape it to that. I guess somebody has some sort of fond feeling for me. Anyway, but I think you need to do something more dramatic. Right now, you're in my own shell. Okay. You know your own theory so well that it is incomprehensible to you that others are not getting it. Well, I've sort of made that clear. I've said that actually in videos. How can you not get this? I mean, I've said these words, and I'm trying to put it in as simple a language as possible. I'm trying to say, look, let's go through it step by step. Do you understand that relativity isn't based on a huge pile of evidence? There's not a huge pile of evidence saying there's a thing called bent space-time. Bent space-time there's no photographs of it. There's no videos of it. There's not a huge amount of evidence. And the evidence that exists is all tangential in the sense that it's not directly connected. There's a connection between clocks breaking and velocity. Yeah, that's a strong connection. And there's a strong connection between the idea of relative, in the sense if we're both going 50 miles an hour, I won't see you going 50 miles an hour, and you won't see me going 50 miles an hour. So there's a kind of relativity. But yeah, there's not dimensions and all that. No. I'm sort of trying to explain it I'm trying to put it in baby talk. But anyway, let's see what he says. Your own theory so well that it's incomprehensible to you that others are not getting it. We have the same problem, James. Anyway, and that and that is not good for the selling of your own theory. Well, the idea of selling it just really shouldn't be my obligation. All I should do my only obligation should be to make good arguments, to ask relevant questions, like why isn't there a sine wave in photons in the two-slit experiment? Those kind of why. I ask questions like, how does the wrong shaped lens create a thick Einstein ring? You know, I can ask, all I can do is ask these questions and have the expectation eventually somebody with a brain will try to answer them. But that's all I can do. Oh, we have some live comments. Okay, let's see. Great job. Oh, I'm sure I'm not going to like this guy. Your videos are insanely long. Yes, I'm a conversationalist, and I'm looking to have conversations. I think physics is a complex subject, and you need to talk about it. That's the way it works. You can't just say something like virtual photon, there, we're done, aren't we? Bent space-time, there, we're done, aren't we? No, you're not really done. I don't think it's justified to bitch about multiple comments on one of your huge videos. Well, why? I think it's I don't think it matters how long the video is. I said right in the comment, didn't I? If there were different subjects, the comments, it might be okay. Didn't I say exactly that? But these are just trivial comments. You know, if you're just making trivial comments, there's no reason to have 5 trivial comments. All right. How else is he supposed to address comments? All right. Not being emotionally triggered by every third word in every single comment would be a start, Sid. So I shouldn't take words to mean something, especially when people put them in capital letters. They often put the words in capital letters. You know, like they're emphasizing at me, like I have to respond to this accusation they're making. And somehow I'm not supposed to do that, okay? I'm supposed to just read your comment and say, oh, you're just complaining. Delete. I'm not supposed to recognize, oh, you're constructively criticizing. Oh, yeah, see, it took a little more work to see that you're making a constructive criticism and you just did it poorly. But no, you don't want me to do any of this analysis. You want me to judge the comment by its cover. Yeah, well, I don't do that. So too bad. It's his page. He can do whatever he wants. It's not a matter of wanting. It's just a matter of that's how I interact with people. That's how I interact in conversation. I think details are important. I think the words you use are important. I don't use words frivolously or trivially. If I say something like, you are, you know, not a nice person, I probably mean it. I forget the name of these videos, Draft Science. I forget the name of these videos, Draft Science. I just found it again. Okay, I see it's live now. Yes, you're commenting. So yes, it's live now. Is this really live right now? Yes, it is. I always love the host confidence and passion. Okay, that's just funny as hell. Also love that the host isn't afraid to let go of an existing model for a new one. I said this open mind thing. I really don't like the idea of, because frankly, most people open their mind to truth or nonsense and religion and nonsense. They just open it to bullshit, to silly Sasquatch and talking bears, and they open their mind to silly crap. So having an open mind is almost a bad thing. Your mind should be closed when you start acquiring facts. You become an adult and you start realizing that, oh, people lie all the time and everything's a fairy tale to most people and they can't get anything. They can't witness anything and describe it accurately. You know, 5 people go to the same thing and they'll describe it in 5 different ways. I mean, it's just so bad. And so that's what you do when you become an adult. You start to realize everybody's full of shit. Digested food. I saw a video over a year ago from this host. Favorite insight I ever heard was when he said time is a function. Yes, isn't that interesting? Seems like somebody should have said it before me, but yes, it's kind of obvious. Time is just a function. It's you know, it's almost like digestion. You know, it happens in a sequence, in an order. You know, The fart doesn't come first. It's not anything by itself, but a function, a composite of other phenomenon. That's right. It's just a byproduct of the fact that it takes time for things to move from here to here. That's all. That's all time is a consequence of the fact that movement takes time. All right. Oh, this is live. Is. See? So now you're emphasizing a word. Oh, this is live. Yes, it is. Wow. That should have been in capitals. Well, thanks for taking the time to share your thoughts. Fine, good enough. I would thank you also, except most of the commentary was completely irrelevant. I mean, except for the little bit about time. That's a good subject. I was thinking about the time thing. So yeah, I might as well do a little bit of physics. Another argument against relativity. So they have these things like the Lorentz, what do they call it? Contraction? No. Lorentz factor? No. Lorentz transformation. And so they basically take a line that would be proportional. That is, you get 2% heavier as you eat 4% more food. And then you get when you eat 8% more food, you get 4% heavier, and it's a progressive line. And they change lines like that with transformations into lines that go like this. Okay, so to avoid this line, what the consequences of it. So for time dilation, see, there's no time dilation halfway up, like 50% the speed of light. No, there's not 50% increase in your time dilation. No, there's a tiny, tiny increase. So see, for time dilation, it goes like, the line goes like this, and they call that a Lorentz transformation because they fixed the evidence. Now they can explain why we don't see a lot more time dilation at common speeds. And but I was thinking about their little bogus crap where photons always shoot to the future. So the light clock, instead of the photon going perpendicular up and down in a light clock that's moving, right? They make the photon go this way, okay, with the motion. Now that's not Lorentz transformed. That's this line, okay? So they use the Lorentz transformation when it's time dilation, but when it's photon migration, momentum change for photons, the headlight effect, I think it's called. The headlight effect, somehow that's not a Lorentz transformation because at half the speed of light, you have a 45-degree change in the angle of the photon. So a perpendicular photon is now traveling this way, And so why no Lorentz transformation? And then you can get into the whole argument about photons. Why are photons, why are photons twice as affected by gravity? It turns out to be like more than twice, I think, when you really do the math, but because of the squared thing. They take the square off the inverse square for photons. And how that messes up this whole light clock thing too, because that's not Lorentz transformed anymore. So these are pretty good. I think they're pretty good questions. All right, question for the host. If it is true time slows as velocity increases, well, time doesn't slow, so let's quit playing the game. You're doing this. I'm bouncing up and down. If I move, you can sort of understand the bouncing ball, like if it was a basketball. You're bouncing a basketball straight up and down. You start to go forward, the basketball has to travel a longer distance to get to your hand. You get it? It has to go a longer distance, but the ball is going the same speed. So it takes longer for the ball to hit your hand. There's no time dilation. There's just a change in the physical mechanism. But time doesn't change. The clock changes. So if you think the clock is every time it hits your hand, that's what you call a second. Then you can understand when you're moving with the basketball, the clock will seem like it's ticking slower, right? That's all. The clock is broken. Time isn't broken. The clock is broken. So to say time slows, time doesn't slow. All you can do is break clocks. You can break the ruler. You break the thing you're measuring time with. That's what gets broken. Time never gets dented, never gets damaged, never gets hurt. All right, time slows, the velocity increase. Does this mean that since a photon is traveling at the speed of light, does this mean time stops? That's there's competing theories. Some people say if you really could ride on a photon, everything would happen instantaneously. So you wouldn't even know you went somewhere. And then other people say, no, you would experience everything at half the speed. I mean, twice the speed. Yeah, well, anyway. But obviously Einstein changed the rules for photons. So clearly a photon thinks it's getting hit. If gravity was a radiant force, like a light bulb, a gravity in physical fact, as described by the best physicist in the world, the most highly paid physicist in the world, will tell you that gravity is essentially bent space. Relativity, the theory, is a convergence. It's a flow. And it's exactly the opposite of a light bulb, you could say. And that's why it's the inverse square law. Okay. And what Einstein basically did is said somehow photons are going in, they think they're going slow. And so by thinking they're going slow, somehow more light is hitting them, so to speak. So because they think they're going slow through the gravity, they think they're getting hit by more photons. Obviously, gravity works in the exact opposite. It's a pulling force. But I'm just saying it's the same effect, that somehow they're getting affected by twice as much pulling because they think they're in the gravity twice as long. I mean, that's not very solid evidence, right? I mean, it's not logically, it's not a good logical foundation. All right, let's see. Just something I've wondered about. Does this mean that time stops? No. Okay, just something I've been wondering about for some time. Yes, time is the same every single place in the universe. And all you can do is break clocks. So that's all you can do. Time is always the same. Photons always take the same amount of time to go from one place to another. It never changes. Time is always the same everywhere. And all you can do is break clocks. All right. Just something I've wondered about for some time. Well, anyway, that's my opinion. All you can do is break clocks. Obviously, their opinion is something more ludicrous, to be explained by virtual physicist at some later date. I follow you. I never felt right that time speeds up or slows down. I understand what you mean. Good. Let's see. As I understand it, this is Diamond Dyer. I don't know. Bearhead guy? I don't know. Looks like a bearhead to me. Call him Bearhead. As I understand it, relativity only pertains to measurement. So obviously it doesn't. I mean, you can't keep saying that it only pertains to measurement when clearly they're arguing photons are traveling a different path. You know, like if you did have a light clock, for example, in the object, they're clearly saying the photon's traveling a longer path. So it can't just be measurement. Somebody's actually seeing it travel the path and has nothing to do with reality, matter, motion, or change. Clearly, that's not the physics they're arguing. They're arguing for real physical effects, like the headlight effect, this effect where as you move faster and faster, all the photons you emit change their direction and start all moving forward. So they start to form a headlight. So any light that was bouncing off your butt, so to speak, your rear, is all of a sudden now move forward. Those are real physical facts. You can't say that that's that's not what they're saying. That's a physical change in the physical universe. It affects everything else in the universe. So you can't say they're agreeing with me, because obviously they're not agreeing with me that it's just broken clocks. All right. Thanks for correcting that. Let's see. Indeed, on your comment, time is the same. I intuit this to be true as well. Yes, the only thing is you have to logically prove it. And that's the part that's irritating. Is you're basically stuck sitting here saying, look, it's water's wet. Time isn't complicated. And they're telling you, no, it is complicated. It's complicated. And the only experiments that demonstrate its complications are all experiments that have nothing to do with everyday life. And so you're stuck having to argue this obtuse. Well, what about when hydrogen nuclei are accelerated to 4K, blah, blah, and you're like, all right, well, whatever. It's just irritating. Time is a concept. It's more than a concept. I mean, it's just wrong to say time is a concept, because concepts aren't always material. And clearly, time is an event. There is no event without it. Again, how can you can't have a sequence. You cannot have anything. Time is the absence of instantaneous. Everything happened instantaneously. And everything can't happen instantaneously because everything's happening in a sequence. So it's not possible. So I'm just saying time is a real function. It's not just an abstract notion. It actually is something that has to take place. The slowness of the photon is a fact. The photon doesn't move instantaneously. That fact means there is time. It's a direct byproduct of a circumstance, not just a concept. It's a direct byproduct. It's a footprint left by the photon not moving instantaneously. It cannot do anything. Functions do, but they do completely consistently. So, of course, they do something. They just don't do anything more than tick their time, so to speak. Oh, what they do is enforce the law. Anyway, when measuring some change, speed and direction affect the measurement. They do not affect matter or motion. I don't even know what that means. When measuring some change, speed and direction affect the measurement. I don't know. Obviously, if you're trying to measure something that's moving in a direction, that measurement's going to be more difficult than if it's not moving. So yeah, obviously, seeing how tall your kid is while he's running around the house is a lot harder than nailing the kid to the side of the door and then measuring how tall he is. They do not affect matter or motion. Well, whatever this means, but clearly it's difficult to measure anything without affecting it, because measurements do require some tangential association. Now measuring, like say measuring a galaxy by the photons that come off of it. Well, they were coming off anyway, so they're for free, so can't do any harm. So if you're just going to measure something by seeing what it's already producing, that measurement's pretty safe. But every other measurement where you take your ruler and start sticking it into the environment, well, now you're likely to be changing the thing you're measuring, because you're going to create a gravitational and magnetic and electric connection to it. Well, anyway, I don't want to get too specific, but it's very difficult to write perfectly accurate declarative statements. So you have to really, you really do have to work on the words to make sure you don't say something that not quite right. I'm just saying it's close, but it's not quite right. Yeah, I forget who it was. Maybe Descartes, who said time exists so that everything doesn't happen in an instant. Yeah, obviously that's saying it backwards. But yes, the fact that everything doesn't happen in an instant is why there is something called time. Direct consequence of that fact. Or was that space exists so that everything isn't in one place? Well, frankly, everything might have been in one place. So frankly, like that could be part of the reason why, there's a Big Bang and all this other bullshit. But I mean, that's, I don't want to get into arguments about that kind of crap. Who knows what condition things can be um, in terms of, we don't know what original conditions or end conditions could be. I think that might be the Descartes line I recall from years back. Okay, well, whatever. I don't care either way. I sort of think I've said it better, so I'll stick with what I've said. you know, but clearly space is just the white space between somethings. Okay, so you can't have more than one something without white space between the somethings. Obviously, if the somethings are in the same space, then they're going to be the same something. They're going to be something else. That's it. The rabbit with the elephant on it isn't a rabbit anymore, if you get my drift. Well, I guess everything is in one place, the universe, but yes, you said it better. Yes. Well, anyway, we both get the point. It's a interesting philosophical concept, but let's not drown in it. All right, back to the commenter. Inconsequential, others not getting it. And that is not good for selling your own theory. Yes, I agree. It's not good. I'm not a good salesman. It's true enough. I hate selling. I just hate it. I used to sell my own artwork, and I can't bargain with people. So I'd be like, all right, $5. Yeah, it took me 3 days, but yeah, okay, you can have it $5, fucker. Sorry. Cheaty person. Yes, you can nag me down to nothing. I've seen many instances where people asked for clarification, perfectly innocent questions. Well, you say you've seen many instances where they've been polite in these requests, and I say garbage to that, but whatever, you can have your opinion. And you snapped at them. Well, I am a little snappy. It's sort of my personality. I'm impatient, tired, fatigued by this whole process. So, but I don't think it's true that I won't answer questions. I do it all the time. I think you need to get out of your shell, whatever that means, but I don't think I do. I need to build a bigger shell, a quieter one. And whatever this is, critically approach. I don't know what that even means. An attempt to understand theories. No, I already understand. I've heard enough religious stories. I've heard enough Three Bears stories. I've heard enough bullshit in my life. I can smell it a mile away. And frankly, I'm just saying that none of you people have said anything that has amazed me. I haven't been in any way, wowed by something somebody said for literally decades. You people suck at saying anything interesting. Just my opinion. That you're not familiar with. Well, I'm saying I don't know what person on the internet you're talking to here. It seems kind of silly. When I deliberately go out and I find other people talking, I watch their videos. I mean, I just did this tonight. I was looking under this, this is so ironic, right? Nobody else does this. I play other people's videos. The David D. Hilster guy, I play his videos. I play the conference videos. I play these damn videos, and then I get this crap from people. Let's see, where was it? Where's the? I did a search, deliberate, whole search. Let's see where this. Yeah, there. physics discussion. So I sat here and and all these videos that have like 48 views, 15 views. And I'm watching these people to see if anybody's got something to say. And unfortunately, they're all speaking in frickin' Hindi, which is really irritating. But whatever. I mean, it's the world's changing and all that crap. But I mean, it's just such a bullshit accusation. I sit there and go, I'm aggressively looking for it. I'm aggressively inviting it into this room. And you're telling me I'm not, oh, you're too closed. You're too in your shell. Amazing crap. I've watched your stupid videos. I mean, it's just, how do you people type this stuff with a straight frickin' fingers? I mean, you must have terribly crooked fingers to type this stuff. All right, anyway. Oh, theories that you're not familiar with. Really, go. Why don't you point me to some brilliant theory, and I'll go, bore it. I will go scrutinize it for credibility, and we'll see if it has any. And you want to put a little bit of a money bet on the fact that it won't have any credibility? If I could find the other credible dissident science person, I would be just begging him to come on this show. begging. Specifically, I'm talking about venturing into other scientific disciplines. I'm amazing. I have the unification theory of physics, the thing Einstein was searching for his whole life, the holy grail of physics. And I shouldn't do that. No, I should go figure out whether you can make edible mud pies out of real mud. No, I shouldn't. I should go find out if there's an herbal medication that will fix this ingrown hair on my knee. No. I mean, can't I put this in the category of just completely erroneously obnoxious, stupid advice? I mean, come on. I should go on people's channels and do this. I think you ought to, and then you should do this, and then you should go get a new hat. And, maybe you should go out to the pet store and watch the fish, because, watching fish is incredibly soothing. And then you should, but no, you shouldn't do that unifying physics thing. That's a waste of time. Amazing. I just, specifically, I'm talking about venturing into other scientific disciplines that you are not familiar with. Why? It's taken me 7 years to get up to speed. I mean, I did have some knowledge of physics, don't get me wrong. I worked in the machine shop. I did circuit boards. I mean, I had some understanding of electricity and circuits and all that kind of crap. So I had some physics knowledge. But I've been spending the last 7 years watching physics lectures, and some of them are horribly boring and uninteresting. And now I should talk about something else than the stuff I spent 7 years learning. Oh, amazing. I think it would open your eyes. Well, I think you ought to go find Jesus. You probably already have. You're already a religious kook. So this is your some sort of Christian advice. Oh, I really hate the idea that I have to be polite to Christians. I mean, just take this stuff, and put it in your own house. Okay? Do this in your own house, whatever this is. And help you improve the delivery of your own message. Well, James, just, I don't know what to quite say that is polite enough. But really, back at you, buddy. Back at you, dude. Yeah, why don't you do some of that, dude? Wink, wink. God, I hate these people. Anyway, can I still say that I hate these people? Anyway, on another note, does the Aneda Sapphire S30 come with Hobolama? I don't know what this is, but no, thank you. Your comment is not terribly interesting and not really appreciated. But fine. Whatever. Thanks. In a sarcastic kind of way. Let's see. Maybe did it. Okay. Or was it space now? Okay. Oh well. Well, I guess everything is in one place. Oh, we already did that. Are you interested in feedback regarding your redshift idea? Yeah, it's fine. Yes, it's a real subject. What causes redshift? Why are things far away? Why they're not really redshifted, right? So this is part of the spectral lines are not where they're supposed to be. They're shifted in their position. Yes, which is a little more complicated than just redshift. But anyway, I mean, it's more than just some spectra of the light being shifted. It's apparently the entire spectrum of the light. Yes, something like that. All right, wait. I gave up on Big Bang Theory. It doesn't really matter. I don't have any opinion, frankly. I don't think it's an interesting subject at all myself. It doesn't matter to me one way or the other. I think clearly the universe is evolving. So I would make this argument that I think the universe is getting heavier. That is all I think the universe is making heavy atoms faster than it's killing heavy atoms. So eventually it's going to get heavy, okay, and cold, and not going to be moving as fast. I got to thinking one day that if everything came from nothing, it's like it's consuming the gravity. You know what I mean? You could almost argue that gravity is getting eaten by the atoms over time, slowly, slowly, slowly. And eventually all the atoms will eat all the gravity. And there won't be any gravity left. Something like that. And then the whole thing will turn back into little bits again, right? Because without the gravity, all the pressure is released. See, that's the catch. It really could be a cycling system, because basically what's happening is that the atoms are evidence of pressure. Every atom had to be created in intense gravitational pressure. It can't be created any other way. And so, in a sense, you have to say it has to evolve. It has to get heavy, and then there's no more pressure, so the whole thing blows up. It all flies apart. The gravity gives up. Anyway, I got to thinking one day that if everything came from nothing, well, whatever this nothing came from nothing thing, I think it's just kind of almost idiotic to say anything could come from nothing. There had to be something, which is potential. So you always had to have something. Then clearly it wasn't truly nothing, right? Exactly. Because if it was, it would still be nothing. Yes, exactly. So obviously it had some character, the character of having potential to turn into something or to have something happen. So something had to have potential. And just a fact, I call it error. I mean, just like evolution is made out of error, like there would be no advancement, no sophistication, no complexity. The whole thing's based on error, you know? So it's sort of ironic that you get sophistication and order by making mistakes. The universe is maybe the same thing. The something is the mistake. The universe was perfect nothing. And then somebody told it, nobody's perfect. And then the universe said, oh, fuck, then I better start making some mistakes. And you start making mistakes. And the mistakes are the something. All right, why did the Lorentz and Einstein ever think up this crazy time dilation theory? What problem was it trying to solve? Well, that gets a little bit tricky. For me to sit there and try to speculate on why. It was clearly in conversation back in those days in sci-fi, talking this whole speed of light thing and the idea of time travel by moving faster than light, and crap like that was part of some conversation. And so I think that's why he ended up tying the two together is because he did do this imagining riding a photon thing, and and so his visions of the universe from the photon from moving faster than anything else moves. I don't even know. Yeah, I can't say for sure how he connected that to gravity, though, or why he would have. Except that you could get away with it. But yeah, I think it would have been better just to stick with bent space, call it something else. I see his answer to gravity is just so vacuous in the sense that it's just a vacuum cleaner. Yeah, I mean, it's just, it has no, it's just some bizarre idea that there's some nothing field that you can move and the somethings will be pushed by the nothing moving. I mean, it just doesn't have any shape or form at all. It has no physical structure. I just don't know why anybody thought this could be a reasonable explanation when you think about it. I mean, it challenges my imagination to try to understand what Einstein was thinking, because it really doesn't make any sense as an answer to the question. It's just as empty an answer. I mean, Newton could have said something silly like that. He could have said, stuff just pulls in, from all directions at once. There, inverse square law. Yeah, it just moves. That's the way it does. It does it. Just does it. Because that's all Einstein's saying. He's just basically saying spooky action at a distance. He's just saying it just does it. Because he has no mechanism making it happen. There's no physical force. There's no energy. There's just the idea that the electron is here and the electron in the next moment is here. And then in the next moment it's here. There's no explanation of what made it move to those locations. Anyway, can you do mud pies and grand unification? Well, I can't. I hate multitasking. So, frankly, so yeah, I can't do. I'm already doing so many things. I mean, I just can't do all of this stuff. I have to. I have to destroy the universe first. I have to explain the universe. I mean, it's just way too many jobs for one man. I often feel that people who turn to religion are intellectually lazy. I have a lot nastier name than lazy for it. But anyway, there's absolutely no rational. You're irrational by definition. It really is true. Faith is belief without reason, and that's all this. It's just unreasonable. There's no evidence. It's childishly stupid. It's a horrible cognitive mistake to fall for a fable. And they settle for less. Probably comes down to them not wanting to be accountable for their intellectual laziness. I think it goes deeper than that. There are still scared monkeys. And once you put the idea in them that there's a magic invisible man with a fly swatter and he's going to hurt you, they get the notion in their head and they're not smart enough to figure out, oh, that's just my psychology doing that. It's like me, I could sit there and say something like, I could find a very beautiful crystal and then I could wish on it, right? And somebody could say, well, why don't you wish you had a smaller penis? Just as a joke, and just because I am superstitious, I am a little superstitious monkey, even though I know there's no chance that my penis will get smaller if I wish on this stupid crystal, I'm still not saying it. I'm just, I'm going to have my fingers crossed or toes. I'm going to somehow I have to get out of it because I'm not going to say that. I mean, I'm not going to wish for that, for fuck's sake. Because what if it happens? Yeah. So that's what religion is. Religion is just a superstition, a silly, insanely stupid superstition. And it'd be fine if they kept it to themselves. If they did that dirty little wank in the closet. But the fact that they jump out in public and do it is so disgusting. Oh, join me in being an idiot. Anyway. All right. And then they self-realize probably comes down to them not wanting to blah, 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 blah. Oh, redshift idea. Question mark. I noticed Hubble said that in the end, he thought he was wrong. Well, it doesn't matter whether Hubble in drawing conclusions was right or wrong. The fact, okay, the data is still right. There is, for whatever reason, redshift. And so you have to explain why it exists. And I think it's reasonable to say it's a sort of an example of the fact that space isn't as empty as we think it is, and that photons that have to travel billions and billions of miles actually do bang into a few atoms on the way. And every time they bang into an atom, they get a little shifted. I really look forward to the James Webb Telescope finally going up. Yeah, I'm not too sure because I'm not too sure it's really a telescope. You know, everything is turned into some other kind of instrument, you know, so I don't know what they're putting into space. I mean, I haven't seen the schematic for it, so I'm just worried that it's not really a telescope. It's just some sort of virtual megascope or something. As I understand it, if you want to measure something that's very far away or moving very fast, well, these are really two very different things, but okay, then you need to do a Lorentz transform to allow for the properties of light. Well, I don't think that understanding is correct. Yeah, I don't think either one of those factors could have anything to do with the path of a photon. So I just don't see how it could possibly matter. Photons, by their very nature, are independent of the thing they leave from. And the only thing you can change is the frequency, that is, in the direction it's moving. So let's see if sound has the same limitation. See, I'm thinking it's, you know, the train noise in the front of the train is compressed, but train noise coming off the side of the train wouldn't be compressed. So the idea is if a photon's coming out, it's not getting compressed this way. You can only compress it in the direction of the things moving. So the only way you can redshift or blue shift is to move towards or away from the object that's going to receive the photon. If you're moving sideways, it's going to get a lot trickier. So I don't see how a Lorentz transformation, that this is part of their bullshit. Sorry, part of their how they confuse the issue is that they're again probably assuming that photons coming off sideways, off something moving this way, they're probably saying that these perpendicular photons are headlighting. And so they're saying the photons aren't really coming off perpendicular. But that would be the only circumstance you'd need to Lorentz transform the photon, in my opinion. And if you do, I'm just saying, even this whole idea of these Lorentz transforms, I think, are based on bogus facts. I mean, again, this idea of changing, you know, you go from point A to point B, and you have a graph. And the idea is you have things that happen proportionally. For every inch you pull, there's 50% more pressure, and then double the pressure, and then triple the pressure, and it's a consistent thing. And this whole idea of making these Lorentz transforms to go from point A to point B, and Lorentz transforms essentially that they're not fixing infinities, they're creating infinities. So that's the whole catch of the Lorentz transform, is to create an infinite nothing and an infinite something, you know, a full 100%. Let's see how to say that. But it's like I said, it's completely unintuitive to not have the 100%. Well, anyway, it has the appearance of a potential gimmick, is all I'm saying. Maybe it's not a gimmick, but it looks like a gimmick to me. And The fact that it's not used consistently makes it scream of gimmick. Because like say something for drag, right? Drag is a real issue for mock gravity. If I made the proposition that drag is a Lorentz transform, that is, you don't have any drag until you get to 98% of the speed of light. So it's only when you're at 98% of the speed of light that you get any real significant drag. You know, they would all probably say, you can't do that. That's cheating. I just imagine if I tried that, I wonder if that would work, where I could just say, no, it's a Lorentz thing, That's why that's why the satellites only get slowed down a tiny, tiny bit, Voyager and stuff. See, there is drag, but there's only a tiny, 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 tiny amount of drag. There's only when you're going really fast, there's a lot of drag. But, just saying do a Lorentz transform fixes the drag subject altogether, just eliminates it as a problem, right? So here's something where they say mock gravity can't work. Feynman said it for this reason. And I should be able to just, too bad Feynman isn't alive. Why don't I just say to him, what if I just Lorentz transform it? Then it's no problem, right? All right, anyway. I find it interesting. Light over 14 billion years away, visible light, shifts to the infrared. Well, again, if you assume that something 14 billion light years away is going to crash through a few transparent molecules, that is hydrogen or helium or oxygen, or, there's going to be a few atoms along the way, and that those atoms would be transparent. That is, they would transmit the photon in a true direction. That is, they wouldn't change its directional momentum. But the process of being consumed by the atom and readmitted by the atom would cause a little bit of redshift. Well, then you could understand that the redshift could just be a consequence of distance, and you'd have this proportional circumstance where the further away it is, the more redshifted, because the likelihood of it hitting more atoms is increased. I don't think that's a completely unreasonable theory. Anyway, hey, Gary, do you know anything about white holes? It's a silly concept, so I have nothing to say on it. Obviously, if there was white holes, they'd be very, very bright, and we'd see them. So what is there to talk about? Very dense objects that are on fire? I don't know. I'm saying that if once you pressure is what causes gravity, causes the pressure. All right, all the little atoms are pushing; they push into each other. So right now we're compressing everything below us. So the atoms 1,000 miles down have 1,000 miles of feet pushing down on them. So it's an incredible amount of pressure of these feet all going down, 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 right? Incredible amount of pressure. And so the bigger you make something, the higher that pressure gets. And obviously, the higher those pressures get, the closer and closer you're shoving protons and electrons. Now, that's very good for making atoms, but it's also very good for crushing atoms. So it really depends. You really can only have certain kinds of atoms in the center. So the more dirt you have inside of a sun, I would argue, the more likely it is to blow up. That is, the more heavy elements that fall back into the sun and get pushed in because they're heavy, they sink. The more likely it is you're going to create something that's going to eventually explode. So it's supernovas. So I don't know how big you can get. I'm just saying that the rules are, I think there's rules to how much pressure you can create. And a certain amount of pressure just crushes the atoms. And once you crush the atoms, you create all the little photons, and they fly back out. And you end up with, a burst of radiation. Anyway. So James Webb will be able to see past 14 billion light years. What was eye-opening to me was that it seems, capitals, Visible light can't make it past 14 billion light years. It drops down to infrared. Well, I suppose this is a valid argument that the visible spectrum is only so big. But you're saying that they redshifted all of the ultraviolet. I don't think they could redshift all the ultraviolet. The ultraviolet would become visible, right? Wouldn't that be sort of the catch here? You'd be turning ultraviolet light into visible light. You can't turn X-rays into visible. That's way too far away. But you certainly could cause the ultraviolet to become visible. So I'm not sure about that. I'm saying that yeah, you'll start seeing ultraviolet light, which might be very interesting. It's just that suns don't create as much ultraviolet as they create visible. I mean, that's the whole ultraviolet catastrophe thing, right? I mean, the sun, the peak amount of energy is like at whatever it is, 400 nanometers or something, and then it drops off. But clearly I've seen some data that shows there are far more out there, some data, the vague and ambiguous data, beyond what we can see in visible light that we can only see in infrared. Well, the point is, the further away it is, the less energy we can get from it. So there's a point where you can't see anything anymore because you're just not going to get enough energy. I don't have a redshift theory, but I do not believe it's analogous to Doppler. Well, I think it clearly is. I think that's how the shift is changed, is in a similar manner, in the sense that you could think of it as dropping paint out of the trunk of a car. And the faster you go, the further apart the blobs of paint will be. To me, that works both for sound or for light. So and the compression thing is the same thing. If you're dropping the paint out of the front of the car, the faster you go, the closer they're going to be to each other. Well, you have to be throwing them out. You have to. It's the velocity thing. So they have to have their own. You have to give them a velocity that's faster than you to be able to compress the forward. So I don't want to say those two analogies work. I'm just saying if you just stick with the half the analogy, it works. You have to use a different analogy to do the forward compression. But the idea of just expanding the distance and compressing the distance is kind of obvious. I mean, it's an obvious similarity. That to me is the domain of physics for acoustics, physics of acoustics. Well, again, it's about frequency, which is about period, which is about time between things. And all you're doing is changing the time between them. So I think I think the two are quite similarly. I think they're compared to each other perfectly rationally. Regarding redshift, atoms do not have a skin. I'm not going to argue. I've never argued that atoms have a skin, so I don't even want to acknowledge this comment because I find that really offensive, frankly. So the photons can only hit an electron or proton. Yes, I've stated that. I don't think they actually hit protons, but regardless, I don't think they do anything very interesting when they interact with protons. According to your theory rules, the redshift photons that hit an atom will either bounce back, no, or ... So I have to read the rest of it. No, that's not my theory. I've pointed it out so many times. I mean, I've used these examples of ping pong paddles and the distance between the electrons. I mean, it's just so irritating. So obviously an electron can come in, a photon. So here's two electrons in an atom. Let's just say they're this way, like ping pong paddles. And a photon comes in and it's now caught temporarily between the two electrons and increases the pressure between the electrons. But the electrons can't increase their pressure because everything's arranged magnetically. And so they're going to push back. And maybe the two electrons over here will do the pushback. And they're going to move a little bit out of shape because of the increase in the pressure. So something's going to expand a little bit. Now, a little bit of expansion will open the door and the photon comes out again. Now, with transparent materials, we know the photon goes in, pressurizes the atom, and then the photon comes out. And it comes out in the same direction it went in, the same momentum, the same angular momentum. So it's completely lossless as a system. It doesn't move the atom this way and then move the photon this way. So apparently the atom is so stable that it moves this way. It moves in the direction that it's going to move the photon, release the photon. So no matter where it gets hit, stable atoms, they always move the same. So you can hit them here, here, here. They haven't, like, you can almost argue that maybe the transparent atoms don't have a center of gravity. Of course they do, but I'm just saying, it's like they don't. And it doesn't matter where you hit them, they move consistent. All right, so that's one way of saying it. So I'm just saying, I can't give you all the ins and outs of the details. I'm just saying that it makes sense to me to understand the photon goes in as energy, pressure. The pressure can't be held by the atom. It says, no, I'm not going to be this big. I'm going to go back to being this big. It releases the pressure in the same direction. So there's this time interval. It takes a little bit of time while the atom's moving from the momentum. It releases the photon. It stops moving because it's released the momentum. And all of that went in the same direction. And what happens in that process is there's a slight, tiny, tiny change in the frequency of the photon. That is the distance between the bits that hit the paddle. So we have to understand the photon is more than one little bit. The photon's at least two. So one bit hits, that electron moves a little bit, the next one hits. So you get that little bit of movement. You can sort of understand that sort of has taken a little bit off of the frequency. That's shortened the frequency because now when it backs this way, this paddle is going to be closer. So it's kind of, it's lengthened the frequency. It's pushed this one forward. This one is still going to be at the same place. So now it's lengthened this distance. So when it's released at a little bit longer distance. Yeah, that's the right way to say it. So I'm saying that's a general description that I don't think has any major structural flaw. So don't say things like, according to my theory. Say, according to my interpretation of your theory, or as I understand your rules, or something like that. But don't say that your interpretation or your understanding is what I've said, because that's not always true. Not even close. Anyway. Okay, according to your theory rules, the redshift photon that hit an atom will either bounce back. None of that happens. The energy is always absorbed. Absorption is a reflection. Yes, energy has to go that way because something moves this way. But then something will be released this way, and that's the same as moving something that way, I mean, when you stop something from moving, it's the same as starting something moving. Deceleration is the same as acceleration. All right. I can picture a book, The Necessity of Error. I can see that actually. Makes sense to me. I don't know if I really like that title, but okay. I like error. My title, error. Warning, Will Robinson. Warning, warning. That's a good title. All right, so he says either branch back or be diverted at 90 degrees. No, photons are always electron force. They're always reflective to electrons. Photons are not made out of proton force. They are only made out of electron force. They are negatively charged in that sense. Photons have a negative charge. All right, to be diverted at 90 degrees. So the distant photons hitting atoms cannot cause the spacing frequency to lengthen. So again, you're making these assertions based on just wrong premises. I've been really clear about the two kinds of forces, and that electron force that's why it's called electromagnetic radiation. It's electron force. It is not proton force. There's no 90 degrees leaving the electron. Hence redshift. Hope that makes sense. The atoms cannot cause the spacing frequency to lengthen, hence redshift. Hope that makes sense. Now, well, it made sense, but I don't like the way you said it. And I think you misunderstand my theory. All right. Let's see. Here we go. We've got a ton of shit here. Well, at least you people are participating. See, participation is good. I like this. This is the way it should go. If there's misunderstandings, we should clear them up. This is all good stuff. Might be boring to some other people, but I find it interesting to see what people are thinking and how they're interpreting what I'm saying. So I love that part of it. So let's keep doing this, even though there's a ton of it here. I wish they would number this or something so I could tell when it jumps where it jumped to. Oh, it's really irritating. Okay. You mentioned the word potential earlier. I just found myself thinking maybe that's closer to what space really is, more potential. Well, I think space is nothing, and I think we're going to leave it at that. And there's somethings in it. To me, that's how it works. The somethings came from a ambiguous thing, a queer, queers made the universe, that maybe that's the way it works. A queer did it. Maybe they should have called like the Higgs queer, the boson. Anyway, okay, so if you spent the last 8 years watching physics lectures, but you can't answer my simple question. Well, you want to be obnoxiously rude, and this is obnoxiously rude. I'm sorry, I don't have to tolerate this. I've answered thousands of questions, and I'll continue to answer questions. And it's just a lie to say I haven't answered a question, just an absolute lie. I think that's proof positive that you really aren't actually intellectually curious or open to new ideas. What question do you have? You're a rude and obnoxious jackass, and if this is all you can say on this board, I'll just delete you. That's the way it's going to work. Okay. I'll try to form better worded questions and comments. Thank you. But don't do that Flamangi thing. I don't like those things. They're like small penis crystals. Love your critiques of Electric Universe and Bill Gates' ropes, and was delighted to hear your ideas on redshift. I just think there is a better non-inflational explanation for the cosmological redshift. Well, I think there's clearly problems with inflation, especially the silly part, where the 1 millisecond after the universe exploded, it quadruple exploded. Zopzoople exploded, or whatever the fuck whatever the silly part is, where it got 99.99% much huger. Just went boing to this big, huge position. And somehow all the cosmic background radiation did the same thing. It boing too. So somehow The stuff moving the speed of light moved a lot faster than the speed of light. I mean, it creates all kinds of paradoxes and nonsense that you're just saying, why are they doing this? And it's just so complex to have to weave through it all. That is it worth it to try to prove them silly? To go through all this mathematical crap and all this garbage to try to just prove to them that you can't do this. It just doesn't work. All right, anyway. I mean, I still don't understand how they do the expanding universe and end up with cosmic background radiation. I don't know how they associate the cosmic background radiation with the origin of the universe, and yet somehow it survived the expansion. How did it do that? All right, the last thing I recall reading about redshift theory is that light collides with electrons in the path of the photon. Now, this I agree that this, I'm saying it's atoms because colliding with a single electron, okay, you can't really do anything but move the electron. I mean, a single electron absorbs the photon. I don't think a single electron can produce a photon. So that's the catch. Now, the trick is I think muons are actually double electrons. But I don't want to get into that argument. Anyway, and that was a vast amount of free electrons exist in space. See, I don't think that can be true either, just because charge is a real thing, and electrons are charged, and they will not stay still in space. So it's not only are they affected, let's just say they weren't even affected by gravity. They are affected by charge, and it's just a fact that there's going to be more charge mass on one side of them than there is on the other, and forward or back. There's always going to be some place that has more charge, more positive charge, or some place that has too much too much negative charge. So electrons want to migrate somewhere pretty badly. So I don't know exactly how electrons get into empty space. So I don't think there can be that many free ones. They're going to stick to dust. Anything that comes by them, they're charged. They're going to move towards or away. So I just don't buy that argument. I don't think so. And clearly, space isn't a very good conductor, which indicates it really can't have too many electrons in it. But anyway. It's an interesting subject. I can't say, I don't know if I have enough to say completely, but I would say that I don't think a photon survives hitting a free electron. If a photon hits a free electron, truly free, that's not associated with any other matter, it's in trouble. It's coming back at you. Anyway, and that the vast amount of free electrons exist in space. Yeah. Well, like I said, I'm not too sure about that as a fact. Sorry, Gary. Tim Mintz is filling in between totally different subjects. Yeah, well, I read your comments independently of his. My Lorenz comment was about the time dilation theme, nothing to do with redshift. I don't think I assumed that it was anything to do with redshift. But whatever, fine. You seem a little anal. Anyway, I'll lighten up on chat. I just returned to Gary's videos after a year or so of not seeing them. The chat aspect is new to me. I don't like it, but I don't mean to introduce tangents. I do like it, though. Whatever. I don't, so, I mean, it's the way chats works. People have a right to do their thing, and you have to do it on top of each other, and I'll get to it eventually. I guess that's the only thing you can do is say, well, they'll get to it eventually. I mean, you can see how far I'm behind, and you can judge whether there's any point in typing anything else, because maybe I'll never get to what you're typing now. By the way, how's that dangerous? UV radiation down in NZ. I don't know what that even means, but whatever. New Zealand, North Zandia. I don't know. It's the worst on the planet. These comments I can live without. I don't know what any of this crap means. The last comment was to diamond, or whatever it is, diamud, id. Okay, I'll not type unless it's something. Germane. Oh, yes, fancy word. Yeah, I agree. What you are saying is actually on par with what I've been reading. Indeed, the greater the distance, the more distortion happens. I think it's a reasonable threat. I guess that's theory. Gary, at theory on redshift gets me thinking. Things really far away. I wonder if they drop even below infrared, maybe into microwaves, etc. Yeah, well, this is one of those things where you really do have to think about it, because actually a doubling, like if you go from like 100 nanometers to 200 nanometers, that's a doubling. Okay, so you're talking about twice as much distance. So you're talking about twice as much time in a way. So you're changing the period by twice as much time, which is a lot. So you can't, I don't think you could ever redshift, like even if you took something to twice the speed of light, I mean half the speed of light, you'd only end up with a doubling of the frequency, I think. So you can only really take something from like, 400 nanometers to 500 or 300. You can't, yeah. Or you could take something from 400 to 200 or 800. I meant a doubling of that, a doubling or halving of that number. So it can't, you're never going to take the 10 nanometer X-rays and boost them up to visible light, 400 nanometer light. It just ain't going to happen. Gary, that theory on redshift gets me thinking. Okay, you ready to do that? Well, UV would redshift down to visible. Yes, UV is possible, but nothing too much higher. Yeah, I didn't think about that, but I can see that. Like I said, the trick is suns don't make a lot of UV. They make it, but they don't make a lot of it. They make a lot more visible light. They make a lot more in the 400 to 600 nanometer range than they make in the 200 to 400 range. It really drops off. It goes, nice line going up, and it kind of crashes after you get to about, let's see, you have to keep thinking these are bigger numbers, right? Nanometers. So the numbers are bigger where the slope is smaller. So, so anything like 400 nanometers is where it all kinds of just starts crashing. And that's when you start going below 400 is where you're going into the ultraviolet. All right. Lorentz transformations have no effect whatsoever on light or matter or time. Well, I don't know what you're talking about, but fine, whatever. Or reality. Clearly they think so. So I don't know what you're saying. Only on measurement. I'm not going to keep arguing this. The headlight effect is a real effect. There's real effects. I'm just not going to, I'm not going to interact with you in this mode where you're telling me what they're saying. I've seen what they're saying. They're saying relativity causes real effects in the world. They're not saying it's a misperception. They're not saying people are deluded. They're not saying they're seeing it wrong. So don't keep telling me that they're pretending that they agree that it's broken clocks and broken perception. Because they're saying I could be in the spaceship moving half the speed of light. They're telling me that if I shoot a laser beam perpendicularly, it's going to stay perpendicular. They're telling me that the light photons aren't going to be left behind. They're going to just keep moving with the bus. That photons are just like a baseball and that I can throw it back and forth in the bus. They say, this is what they say it does. So don't tell me it's perception, because perception doesn't answer the question. Two spacemen are sitting in space, moving together in orbit, and they're throwing a wrench back and forth, and they're moving. The fact is the wrench isn't going back and forth. The wrench is moving a longer path. That's a fact. And the argument is that photons don't do that. Photons don't carry two momentums. I've been over this 4 million times. Photons leave perpendicularly. So when the two astronauts are moving, if you throw a photon, the photon misses the astronaut. The astronaut's moving on the bus. We're moving together on the bus. I throw a photon. Photons aren't moving with the bus. The photon goes perpendicular. It misses the astronaut. The wrench goes forever. Photons are not baseballs. They say they are. That's wrong. Jeez, annoying as hell. So don't tell me transforms have no effect whatsoever on light. So don't tell me that, because that's not their theory. What about when they flew clocks on jets and they slowed down? So again, just understand, yes, the clocks decayed slower. Yes. All right. Rusty pelican, rusty mullet. What does that mean? God, I hate people that type incomprehensible gibberish. Oh, look at that. We're done. We're caught up. I thought I'd be way behind. All right. I struggle with these studies of atomic clocks that had different readouts. There's problems with some of this stuff, the way they do these experiments, but I think it's clear now they have done some pretty good atomic clock experiments just by doing height differences. Top of a building, basement of the building, and measured the difference in the time. So I think it's a pretty well established in the sense that we can kind of all agree that yes, and the velocity that's different. Clearly, there's more gravity. You know, the closer you get to the surface of the Earth, the more gravity there is. So, you know, and the more gravity, the more acceleration you have. The more acceleration you have, the more velocity you have. You're effectively, I've made this argument, but you're effectively bouncing in gravity. You're being pushed down, and then you go back up, and then you push down, and then you go back up. That's what the atoms inside of you are doing. They're always doing this kind of stuff. And you're moving on the surface of the Earth in a direction, so you can sort of get the idea that you're doing this at least line thing. So you're traveling very long lines. So you must be your atoms are going much faster than you are. The atoms inside of you are traveling those longer paths. And they can go faster. Their speed increases. So the clocks on Earth are the ones that have to be adjusted, which is the funny part. It's the Earth clocks that are moving slow. We're the ones time dilated, not the satellites. That's the irony. The fast moving satellites, the satellites that appear to be moving faster, they're not really moving faster than we are because they're not going up and down as much. The basketball is bouncing really low to the court, so it doesn't travel as much distance. We're bouncing the ball really high, so the ball has to travel a lot more distance in the same amount of time. So we're the ones, our atoms are the ones going really fast. I use the word leasing. So it's like that idea where there's a jagged edge on all the fonts in the old days. It's a leasing. Everything leases. The Earth leases around the sun. It doesn't go in a perfect circle. It's jagged lining its way around the sun. Everything's bouncing its way through the universe in a way, in a sense. I can't say everything, but I'm just saying every big thing you see is bouncing. It's jiggling. It isn't moving a straight line like a photon. So anyway, it's a pretty good room. I'll stay a little longer. Didn't even have to talk to the virtual physicist. So I was going to ask him a few questions. But, you know, the trick is I can't even make up the answers. I thought about, man, yeah, okay, I'll just go something like, what about the energy problem in physics? You know, where you don't have any energy. Oh, I'm supposed to do it with me here. Yeah, where you don't have any energy, you know, like you just make new energy. You kind of create energy with bent space, and you create energy with magnetism because you don't have a trail. There's no trail. And if you don't have a trail, like in magnetism, for example, how can you have a holographic universe where everything is remembered, you know, if there's no origin for the energy? That doesn't make any sense. Are virtual photons in the holographic universe, Mr. Physicist? Well, yeah, well, you know, that's what some people say, you know, and that's physics. Well, that's not, you know, well, what am I supposed to do with that answer? Oh, yeah, some physicists say so. Oh, great. So I have to go find them and argue with them, right? Because you won't say, oh, yeah, that's what I believe. Thanks a lot. Anyway, that's what I was going to do. So thank you for saving all of us from that. I am so glad you're still doing videos. Yes, well, I'll probably be doing them till I'm dead. And then half the people will be very happy and half of the people will be very sad. It can get emotional at times, even a bit out of control, but the passion is real. No, it's not even that the passion is real. I just happen to be a real person. And yes, I'm not a, I'm not pantomiming. I'm not reading somebody else's script. I'm reading my script. Yeah. Yes, I want the truth. I don't want to be wrong. I don't want to be selling crap. I don't want to be promoting it. I don't want to like shake the hand of a, horrible person and say, thanks for being my friend. I don't want to be a fool. So yes, I don't want to fool anyone. I don't want to lead anybody down any wrong roads or horrible pathways. I'm only speaking what seems urgently, in some respects, important, and what seems that deserves. Okay, it's almost like I feel sorry for the truth because it's been mired and held down and beaten up by this, by bully religion and by, wishful thinking and all of these, to be trampled by the three bears. I just feel sorry. The truth just keeps getting trampled by all this nonsense. Yeah, so I do have some stuff for the virtual physicist, and I just have to write some more stuff. I just haven't finished getting to all the details of it, but I do have some stuff here, to ask virtual physicist, and I will attempt to, as honestly as possible, answer the question. I mean, if a real physicist won't show up, I'll have to contrive their answers because somebody got to answer these points. But they have this energy problem, and it's obvious. It's most obvious in magnetism, right? So the word virtual photon. I mean, shouldn't every physicist have to explain how is virtual photon an acceptable explanation? I mean, can't we all just agree that you have a huge problem when you have to resort to phrases like virtual photon? Come on. A non-existent energy source, right? So first they're saying a non-existent energy source creates this phenomenon, and somehow the non-existent energy source can tell when the magnet is this way and when the magnet is that way, and the non-existent energy source figures it out and then smashes the magnets together or throws them apart. That's what physics says happens. That's how vacuous their answer is, and yet they're so arrogant. We know we can read the holograms on black holes. They think they can read the holograms on black holes, and yet they can't answer the simple question: why do the magnets smash together? I mean, it's pathetic. I mean, why is it legitimate not to answer that basic question and then presume to answer it and tell me there's a Higgs boson, and then tell me that, well, yes, black holes collide with each other and the matter inside of them doesn't convert into photons and electrons and gamma rays and other kinds of radiation. You know, the particles inside the mass of all that matter, 3 solar masses worth of mass, is converted into virtual gravitons thingies, bent space arisers. You know, bent. I mean, it's just, you can't even. What are you talking about? Matter turns into bent space? How did that happen? Who said that was possible? I mean, I'd love to hear a physicist answer that. How does matter get converted into bent space? Not radiation, not flying electrons, not flying protons, not speeding photons, not anything we know of. No, it gets turned into space-time. I never intuit Higgs boson was a decent model. Well, I don't even know. I don't think it is a model, frankly. I mean, I don't know how it's a model, right? It's not a field, and it has no power as a particle. It only has power as a group of them. Somehow they make things stick together. So they're like a gluon, but they're never attached to anything, but they're somehow a field of, I mean, it just doesn't make any sense. Seemed like it was like a dentist filling a tooth. No, that sort of makes sense to me, but at the same time, drilling an even bigger hole. Well, sometimes to fill a tooth, they do have to make the hole big and put little ridges in it so the filling stays in. You know, that's part of the problem with dentists. Yeah, the new glues work so much better, though. I have some glue teeth. You know, they're not even teeth; they're just glue. I once learned that Sears fission is from gravitational friction. The sun's fusion. Okay. I once learned that the sun's fusion is from gravitational friction. Well, there's torque. You know, the sun is being torqued by all the planets. It's probably being torqued a little bit by the galaxy. But the real point, the real thing the sun has is pressure. It's gravitational pressure. It's not friction, it's pressure. Gravity creates pressure. Gravity comes from the outside and pushes in for everything. Everything's under pressure from gravity. This concept of a black hole to me, question mark, this concept of a black hole, dot, 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 to me, question mark. I don't know what that means. They can't have gravity. Well, of course they can. If they have mass, by their theory and by my theory, the mass consumes velocity towards the center of the mass. So it absorbs energy. And by absorbing energy, the energy doesn't get somewhere else. That's gravity. They convert any mass to electromagnetic, yes? No, they don't really do any of that. So electromagnetic is just a phenomenon. When you polarize atoms, you cause the energy that goes through the atom to be magnetized. That is, it comes out as magnetism. So the gravity goes in, magnetism comes out. But that's all magnetism is. Magnetism is not, it's just a consequence of filtering force, segregating electron force from proton force. But anyway, I don't want to get into that. Electromagnetic energy is supposed to be gravity, just like any other mass. Let's see, electromagnetic energy is supposed to have gravity. Well, that's silly. just like any other mass. Electromagnetic energy is just photons. Photons don't have mass because they're not matter. I mean, they cause pressure. They don't feel pressure. They're the force. That means they create the field. The force is the field. I said that right here. The field is the force. See, they are the force. They're not the thing affected by force. They affect matter, and matter affects them, you could say. But otherwise, the two things can't. Matter can't interfere with matter. Force can't interfere with force. It's only the hostility between the two that permits anything to happen. All right. But reading further, what I was getting at is if pressure of the sun converts mass to energy, tricky. No, it's doing both. It's converting energy into matter, clearly, in the sense it's making atoms. And at the same time, it's clearly leaking some energy. So yes, you could argue that in the process of making heavier atoms, it's releasing more mass. It's losing some mass to energy. Yes, so it's consuming matter from the universe, well, from the solar system anyway, dust, dirt, whatever it can get, and it's leaking a certain amount of energy. Now, whether it's leaking as much energy as it's actually consuming, it's still consuming stuff. So, that's a tricky question. I don't know whether the sun is actually getting heavier or getting lighter, because I would surmise that it's getting heavier, that it's still collecting more dust than energy it's producing. But anyway, the sun converts mass to energy. Then a black hole would have even more pressure. Yes, but it doesn't have to be doing any hydrogen converting into helium. It doesn't have to be doing any nuclear fission or any other processes. So it could be very hot, but depending on what the stuff is it's made out of, it won't be converting it into other atoms. So if it's made out of atoms that are stable under high pressure, like maybe tungsten, you could imagine some very stable element. Then it could be under fairly high pressures without something bad happening. But I would still argue that the pressures, and we're talking about they talk about black holes the size, 1 million solar masses or something. I don't think there's any chance that anything like that could exist. But something that could be 5 solar masses or 25 solar masses or 1,000 solar masses. I don't think 1,000 is realistic. I'm just saying it's, because the pressure multiplies by the inverse square law. So, this gets a little complicated. But I'm just saying that, I don't think so. And once the mass is converted, I think gravity isn't there anymore. Well, I'm just saying that's obviously the mass is what's absorbing the photonic energy of the gravity. So if you understand what I'm saying about gravity, it's like photons. It has real energy. It gets absorbed by things, and therefore the energy doesn't go where it was going. So for this to move, it has to absorb the gravity energy. That means the gravity energy was going the speed of light doesn't get somewhere. That's the gravity. That's what makes the other thing move forward, is because the energy from pushing it is stronger than the energy coming from the other side, because I'm absorbed the energy coming from the other side. It's not getting there. So the two things move towards each other. Obviously, if I take away the matter, I turn the matter back into photons or little bits, the energy is now released. It's going where it was going. So it's not getting absorbed anymore. Therefore, you lose a part of your capacity to absorb energy. You need the matter to absorb the energy. If you don't have mass, you can't absorb as much energy. So it's just that simple. When these two things fall, they'll fall at the same rate, but this one will absorb a lot more energy than this. The heavy thing absorbs a lot more energy than the little thing. They move at the same speed, but they're absorbing a completely different amount of energy. Even more pressure, blah, blah, blah. I hate this jump thing. And once the mass is converted, I think gravity isn't there anymore. Alas, I don't think black holes exist. Well, I think dark masses exist, but I don't think, yes, I don't think the preposterously dense black hole is a reality. Just think it's kind of obvious, but whatever. It just kind of doesn't make any sense. But anyway, it's not really a conversion. Energy is mass. See, this is messy. This is where you get into real trouble with language, because I might have said 4 months ago that was okay to say, but in a way it's really not. Because electrons are not energy. They have no energy unless they're pushed. So in a sense, they don't have any energy unless you broke them up, smashed them somehow, and then maybe there's little bits inside of them that would fly out at the speed of light. So they would be made of energy. But being made of something and being convertible into something are two different things. So I would argue that the elementary particles are not easily converted. It's very hard to convert an electron back into energy. Mass in particles is converted into energy. So again, it's just a little bit messy. The pressure, the energy has to be trapped between paddles. Okay, so the energy is ping pong balls, and ping pong balls only care about there's only two things that decide how much energy there is: how many things are bouncing, interacting in a system, and how much pressure, that is, how close the things are. The closer they are, the more they've been pushed together against the pressure. So those are the only two things that matter: proximity, closeness, and number. So you can increase the number to add energy to a system, add pressure, or you can increase the pressure. You can push them literally closer together and there'll be more interactions, more pressure. So it's proximity and volume of photons would decide how much energy or mass an atom has. No, how much energy it has. Yeah. And obviously you have some liberty through ionization and other things to change the mass of an atom. Okay, energy is mass. Mass is mass in particles. The tricky word again. What kind of particles? Again, I mean, the atomic bits are different than the force bits. And that's where this gets a little messy. Mass in particles is converted to energy. Now, the energy was already there. It was just released. The energy is trapped between the electrons and the protons. So it's just about the stuff they have trapped between them that are keeping them from crashing into each other or being, and the outside pressures stopping them from flying apart. That's all there really is. So there's just this, I don't want to go into it's magnetic. So it has to do with the fact that the red force bounces off of the protons, the black force bounces off the electrons, reflects perfectly, and it perpendiculars out inversely on the two things. And so you have a way of creating less pressure and more pressure between electrons and protons. And it is the balance of that attraction, that is the less pressure pulling the electrons towards the protons, and the repulsion, which is pushing the protons away and pushing the electrons away from each other. So the see, how would be a good way to illustrate that in a simple way? Let's just say that white people hated white people and black people hated black people, right? But white people loved black people, and black people loved white people. You could, however you put them in a room, you would understand that they would have to be in certain relationships to each other for them to get close to each other. You'd have to have the right order of black, white, black, white, black, white, black, white, or else they couldn't get as close to each other. So for them to get close to each other, the two white people always have to have a black person in between them, that kind of thing. Get it? Well, anyway. Anyway, I don't want to get into it. I can't get, I can get deeper, but there's no point in, well, I don't know if there's no point. I have other videos to watch that you can get that explanation. All right, let's see. I think gravity isn't there anymore. Okay, it's not really a conversion. Okay, yeah, I didn't like this comment. And mass energy equivalent says this. I'm sorry, but it's just not, there's no mass energy equivalency. As I've pointed out, you don't even have an explanation for gravity in terms of where the energy comes from. And you clearly, virtual photons is the invention of energy. So there's no point in talking about this mass energy equivalence thing when you make up energy out of nothing, and then do crazy things like convert solar masses into gravity waves, but whatever. The mass energy equivalence says this, no, whatever. This is all standard physics, though, which isn't complete. Well, it's obviously flawed and incomplete would be my argument. So why preach it as if it's a fact that there's a mass energy equivalence when we don't have a good description of what an energy is? So let's just concede. I would argue that my theory tells you pretty explicitly what an energy is. It's something moving the speed of light. A bit moving the speed of light is an energy. Nothing else is an energy, just a bit moving the speed of light. And the matter bits are the dead bits. They don't do anything until one of those moving at the speed of light bits hits them. And so there is no equivalency. The electrons are nothing. They're dead. They have no capacity to keep moving anywhere. They have to be pushed. The same is true of a proton. You have to push it somewhere. And the only way you can keep them moving is to have them in a relationship with each other where they push each other, keep moving in some sort of bizarre spiral. Anyway, I woke up, let's see, to a passion, that means, in exploring physics when I saw that frog float. I don't know what this means. Due to diamagnetism. Yeah. I don't want to, diamagnetism. Whatever. I said, here's an electromagnetic energy completely overriding gravity. Well, yes, but I mean, I don't know. Let's see. That frog. I mean, would they stick a magnet in the frog? I mean, I don't even want to think about what they're talking about. But anyway, what do I want to say to that? I don't want to say anything to it. I mean, obviously, I don't think you can get something to float unless you use a lot of electricity to really control the magnetic field. So I just don't know what that video is, but whatever. I don't know if I want to. I don't even know if I want to look it up. I mean, clearly, yes, you can. Clearly, magnetism is gravity converted. So the gravity goes through a magnet, just like regular gravity. It affects the magnet, just like regular gravity. When it leaves the magnet, it comes out magnetized, that is segregated. So it's still gravity to anything that's not magnetized. So anything that can't see the difference between the red and the black bits hitting it, that thing can't tell it's coming out as magnetism. But a thing that can tell the difference, that is the thing that's weighted electrons on one side and protons on the other side, can see the difference, can feel the difference. And so it feels gravity like magnetism. So once gravity goes through something magnetic can see the gravity as magnetism. and therefore behave differently because it's not gravity to it anymore. It's magnetism. All right, something like that. All right. Black holes not existing. That's interesting, though. I don't know what that means, but okay. Talk about them, Newton. LOL. Talk about them, Newtons. LOL. That's just so useful. What to say? Wow. Thanks a lot. Tim Miltz. A table overrides gravity in the same way. I mean, come on. Can't really be the same way because there's obviously a ton of atoms creating the support mechanism. It's not just force. To say that a laser beam, say if I shot a laser beam and I had a piece of paper and the laser beam was strong enough but didn't burn the paper, theoretically I could float a piece of paper on top of a laser beam. If I could make the laser beam strong enough and I made the paper non-flammable enough. So theoretically you could do that. It'd be kind of stupid to say the laser beam is the same thing as a table leg. Clearly the laser beam doesn't have any matter. No atoms. It's clearly different. All right, anyway. Again, just talking normal physics. Gary's theory might have more answers. I don't know what that means either. Wow, that really threw me for a loop there, that electrons are not energy. I have to digest that. Yeah, electrons are quite dead, okay? They can't shoot one to the moon. I can't make an electron gun and go, bang, shoot the electron to the moon. Can't do it. Electron stops. If you have to push electrons with voltage, and voltage is light. Okay, essentially. I mean, realistically, voltage is gravity, voltage is light, voltage is this little stuff moving the speed of light. So you have to push electrons everywhere. They don't go anywhere unless you're pushing them. All right. To digest that. Yes, if electrons aren't energy by themselves, they're not energy. Yes. Where does the energy come from when electron and positron? Well, I don't believe there's any such thing as a positron anyway. Annihilate. And I certainly don't think anything ever annihilates. I think that's just absolutely silly baby talk. And even the real physicists admit that it's, they're just playing games with words. I mean, Leonard Susskind says these things don't annihilate. An antiparticle is an evacuation from a system. So if I pulled an electron out of an atom, the antiparticle is the empty space, essentially. The vacuum left behind, the negative, I've created a positive condition in the atom by taking a negative charge out of the atom. So they even admit that kind of stuff. So, I mean, but they're, well, so anyway, I don't feel any great obligation to get into annihilation events because I think that's really just as bad as dark matter physics. It's bad language, bad explanations. It's junk physics. You can't create or destroy. And they're using words like annihilate when they're not really annihilated is just such garbage rhetoric. What is all this? How does it jump like this? I don't get it. All right. Let's see. Even though I learned physics belief. I don't remember that. Not curious. I don't know what that means. Voltage is light. Okay, got that. That's good. Let's see. I haven't read this. Just type in floating frog. No, I don't really want to. Whatever. I don't need my physics with frogs in it. Again, just talking normal physics. Gary's theory might have more answers. Okay, there we go. If electrons aren't energy, okay, so yes, annihilations is silly. Okay, we shouldn't say energy is created, so it had to be there. I'm just saying annihilation is, physicists who would play with a word like annihilate, I think have credibility issues. Both work. I don't know what that means. Gary, I'm not preaching standard physics. I don't really care. I'm just saying so far I'm not terribly in love with the way you type. I also think it's flawed. Just clarifying what it says so we can take it apart seriously. Well, I'm just saying some parts of what it says are so distant from being a proven or or in any way established. Like I said, I mean, I'm going to argue relativity and the foundations of quantum mechanics. I don't feel any obligation to argue dark matter because there's just no evidence that it exists. So it's nonsense till they demonstrate that's for some they have some logic that defends their placement of it in specific locations that are just terribly convenient, places that make absolutely no sense. Gravitational substance just stays in a halo around the galaxy. How does it do that if it's gravitational? Okay, just type in floating frog into YouTube. No, I'm not going to do that. It's this 40 megawatt electromagnet in Europe somewhere. Yeah, fine. I'm just saying that, yes, magnets cause levitation. You can watch videos from the 50s. Right? I mean, we've known that for a long, long time, that you can cause levitation, with coils, and but it is kind of ugly, because you got to use voltage and a lot of it, and usually AC voltages. All right, and they drop the frog in a hole of massive electromagnetic, and the frog just floats. Just whatever. Fine, fine, fine. All right, so the frog floats in a electromagnet. Um, just trying to think, just how much. I suppose that's just because of the amount of iron that's in the frog. Man, I imagine it can't be too good for the frog, but okay. I bring it up to physicists, and they always say, "Well, Tim, that's simply diamagnetism, and it's a freak exception." Well, again, I don't think it's diamagnetism. I think it's ferromagnetism. I think if you throw something in, it doesn't have any iron in it, it might not happen. But who knows? I don't know if I want to investigate it, but now that you've planted the seed, maybe I'll have to go look into it. Voltage is light. I do like that. I struggle with understanding electricity. Just the word pressure, everywhere is pressure, and there's just different ways the pressure is imposed. It can be imposed by a laser beam, it can be imposed by, I need the fog. Yeah, not a very good demonstration. But anyway, that is that really is cool. I like it. Anyway, quit playing with toys. It can be imposed inside the wire. It's just pressure, and the pressure is the stuff moving. It wants to move the speed of light. Sometimes it can't, but it wants to. I mean, it's obviously moving the speed of light. It just it gets stuck, having to be absorbed and then readmitted. And so it gets slowed down by that process of dragging the electrons along. All right. Voltage, understand electricity, and that is a new way for me to look at things. Yeah, well, I have to admit, as somebody who worked on circuit boards, I wish I could have talked to me when I was 20 years old. It would have given me a brilliant way of looking at circuit boards. I just would have loved thinking of it that way, especially when I was getting electrocuted. Anyway, just to clarify the simple question you couldn't answer. All right, I'm not going to play with you. So you have to keep repeating this false premise. I'm sick of it. Go to hell. I don't have to accept this. You couldn't answer was, why did Einstein and Lorentz invent time dilation in the first place? Why should I have to answer what Einstein was doing? All right. Obviously, he modified his theory from the first time he published it. And here you are saying the same shit over again. Why do I have to answer any of this shit? I think Lorentz is nonsense. I think it's a gimmick. I think it's crap. There, I've answered the question. Now, don't come back. I don't understand. How do you want me to answer what was in Einstein's head? This is idiotic. Fuck off. Sorry to use bad language again, but I have no reason to listen to you. So Antelope answered him. I did, though. It wasn't invented on its own. It's part of the Lorentz transformations. Yes, there was other people who did transformations. Newton had transformations. Obviously, they all seemed to need some reason to take the line going like this and figure out there must be some other line because this line didn't work. So they had to make some other line. This line. All right. The equation makes Maxwell's electricity equations invariant. Oh, I don't even know how to make sense out of that on the face of it. It's part of the Lorentz transformations. The equations make Maxwell's electricity equations invariant. I gotta remember what invariant means. Eek. Simple point is look, I mean, there's a all of these things have effects. It's like the fact that gravity is 10 meters per second, but we don't accelerate at 10 meters per second in the sense that we don't gain velocity instantaneously. The velocity takes a while to catch up to the acceleration. That is, it never catches up, but I'm just saying your actual speed can't realize the effect of the acceleration, and that the faster you're going, the harder it is to push what's left of you faster. So there are lines that describe those things that have uneven the effects are still they're proportional, but not they're yeah, well, instead of being a straight line, they're parabolas. But it's like how much you can bend a parabola is the question and still be doing something legitimate. Well, they're generally speaking, 70%, I'd say 70% of these rooms are at midnight and, Eastern Standard Time. So the same time this one was. Okay, but yeah, I mix it up. But I can't say when. Tomorrow night, I could say tomorrow night, but I don't know. Just depends. So anyway, this is probably more than enough. Oh, I haven't been here for a while. Hi. Yeah, I was hidden, I guess. Sorry, I don't pay much attention to what the hell's going on the screen. My bad and such. So anyway, it looks like things have slowed down, so it's probably a good time for me to say I should go because it's late, and it's late, and that's all. I mean, I'm really not terribly tired, but it is late. And it is like 3 hours of this crap, so it probably is a monstrously long video. So I should wait to do more monstrously long video. You can't do that all the time. So till the next time, and such, and so forth, and whatnot. Yes, but I'll have to do some looking into Lorenz just to satisfy the ass. Whoops, the jerk. Anyway, I just there's so many people that have names on the internet that I really hate because they take other people's names and use them in all kinds of ways, and it's really obnoxious to take other people's names and pretend you can speak for Descartes or something. Just speak. But whatever. Descartes. I mean, Descartes, I get. I don't Descartes homunculus. The idea of the homunculus is an interesting word, but yeah, somebody who would call themselves that, you just wonder who that person would be. So pretentious. But anyway, it's my impression. People would just be called what they are, or call themselves something relevant to what they're doing on the internet. Troublemaker. You know, you all seem like troublemakers. Troublemaker 1, Troublemaker 2. Just all have numbers. Anyway, I don't think there's anything else I need to throw in here. No, this all can save for the next time or whatever. I just have to make a list of the serious problems that physics has that they aren't addressing, and see if I can get somebody who's a defender to address those serious problems and such. That's all all I can do, mostly. Anyway, till next time and such, so forth and whatnot. There's the button. Okay, so see ya.